Hi guys, sorry about that. I know it gets, I just somehow forget that I'm still talking and it ended. Anyway, this is part two. This is where we ended. We found the slope, correct? To be -3/2. We did the y equals mx plus b way with x being -4 and y being 4. And we got y equals -3/2 x minus 2. We did the y equals mx plus b way with x being 2 and y being -5. And we did the math and got b to be -2 again. Y equals -3/2 x minus 2. We used the point slope form where we take y minus the y coordinate equals slope -3/2 times x minus the x coordinate. We changed minus and negative to plus, of course, distributed our -3/2 through, and we got y equals -3/2 x minus 6, added 4 to both sides, and look what we got. Y equals -3/2 x minus 2. So the only way I didn't show was using the point slope form with 2 -5. So let me try that for you. Okay? Again, it's y minus the y coordinate. My y coordinate is -5 equals slope times x minus the x coordinate. In this case, that's 2. So I have y plus 5 equals, I'll distribute my -3/2 through, -3/2 x plus, negative times a negative is positive, 6/2 is 3. Of course, I'll subtract 5 now to get y equals -3/2 x minus 2 once again. Okay, 4 different ways, same thing each time. Okay, there's lots of ways to solve problems in math. The higher up you get in math, the more you'll find that there are multiple representations, multiple ways to attack a problem. And as long as you're doing algebraically things that make sense, you're fine. You'll get to the right answer, okay? So here's some real life data for you. I don't know if you know this, but the heavier cars are, they tend to get worse miles per gallon. Their gas mileage is worse, okay? The table below shows that. Here's some vehicles, their weight, notice in thousands of pounds. We're not talking about a 2.5, we're not talking about a little matchbox, okay? This is 2,500 pounds, and its gas mileage is 34 miles per the gallon. A 2,900 pound vehicle, it's 36 miles per gallon, etc. Well, I want to get this Jeep, which is about 4,100 pounds. I'm wondering what its gas mileage is. They didn't have that on the list. Well, let's do it with math and equations. Okay, so let's take the same problem that we had. Okay, here's our vehicles. I am going to take this 2.5 thousand pounds, okay, and 34 miles per gallon, and I'm going to plot that. Okay, now I already made the x and y axis, and notice it's different on the x-axis than it is the y-axis, so I'm certainly not going to be able to count my slope, but that's okay. I can still find points and subtract. So I have 2.5, 34. 2.5 is right here. 34 is a little less than 35. Let's go with this. 2.9, 36. That's almost 3. And I'm going to go up to 36. Okay. 3.1, 31. Here's 3.5. Here's 3.25. So 3.1 somewhere in here. We're estimating. Okay. We're going to get the best fit line we can. 329, so here's 330s right here, so a little less than that. 4.2, 23. Here's 25, so here's 22 and a half. I'm going to go with right here. 6.6, oops, I have to move myself again. 6.6, 12. Oh, whoopsies, I went too far there. 12. 3.426, so 3.4, I'm at 20, here's 25, a little bigger. Okay, now I want to make the best line I can right through that data. Okay, So, oops, I didn't mean to do that. Best line I can, here, does that line look good? No. We want it to kind of go through the data, hitting as many points as we can. I don't like that. It should be a little less slanted, don't you think? Maybe something like so. That's gone through 3 of them. I have 2 above and 2 below. That looks pretty nice to me. What do you think, guys? Oh, thank you. I think you're right. Let's go with that. Okay, so then I'm going to pick a couple points. And guys, just pick points on the line. I don't have to use these. I mean, I can if I want. They're fine points. But I could also use, oh, here's a nice point, right? What's that? 3.75. Halfway between, that's, 27.5. Right? I mean, that would be fine. Let's use that. 3.75, 27.5. There's a point. Another point, well, I might as well use, what is this data point? 4, well, on this line, that's actually 4.25. That's too hard. I don't want to look at that one. I want to look at something there. This is nice. 5.20. Why not? I like to make my life as easy as possible. We're going to find the slope. So I'm going to take 27.5 minus 20. Divide that by 3.75. Oh, sorry. Minus 5. That'll give me 7.5 divided by negative 1.25. Do that on my calculator. 7.5 divided by negative 1.25. That gives me negative 6. That's nice. Okay, so that's my slope. But notice what I mean. I certainly don't go down 6. 1, 2, 3, 4, 5, 6 over 1. That's because, 1 here is skip 2 and you get 1. Skip 2, 2. Skip 2, 3. But here I'm going by 5. So you can't just count up and over when your scale's different. Okay, now I want to write the equation. So I'm going to use 520 because that's nice. I don't have any fractions here. So y minus the y coordinate equals negative 6 times x minus the x coordinate. So I have y minus 20 equals negative 6x plus 30, right? I'm distributing my negative 6 through. I'll add 20, and I get y equals negative 6x plus 50. That's going to tell me, if you tell me the weight of your vehicle, okay, in thousands, and then I'm going to, make that into a decimal, but then I'm going to multiply by negative 6, add 50, and I think that's the gas mileage. So let's try it. Oh, whoops. I didn't want to do that yet. Negative, what did I say? 4,100. My car was 4,100. I'm going to go back to my car. Yeah, 4,100. I now have my equation using my real life data. So I'm going to say y equals negative 6 times 4.1 plus 50. Okay, that's what you do with this 4,100 pounds. That's 4,100. Well, as you saw, we make that into a decimal, right? So I'm taking negative 6 times 4.1. I get negative 24.6 plus 50. Okay. And what's that give us? Yep, 25.4. I think I get about 25.4 miles per gallon. Okay, that's my estimate using, how rough was that? Right? It was real life data. I had big dots. I wasn't even close to, I was close. I'm just saying certainly wasn't exact. We didn't have to micromanage it. Here's the real results. Okay, what did we get? 25.4. I put this off the internet, the real miles per gallon results. Soon after test day, we had emissions, and I don't know. This was the Jeep, and the miles per gallon in this is city, highway, and combined. 22 in the city, 24 on the, highway, and 22 combined. All right, that's the estimated, whatever. All right, here's what the real mile per gallons, which were a little bit improvement. 21.4, 26 on the highway, 23. Well, we weren't doing city highway. We're just saying in general, and we got 25.4. Look how close we were to the real miles per gallon for this Jeep that I took off the internet. Okay, they were testing their Jeep. See how it measures up to its EPA. This is the real miles per gallon is right here, and the estimated miles per gallon. Okay. Anyway, isn't that amazing? I just think it's amazing. I love it. And thanks for listening. Good luck with your homework. And I can't wait to see you at the high school. Bye.